Hello, this is Raphael Jaba, and this is my circuit for electrical engineering at Gloucester High School. And what I have here is a Sparkfun tb6612fng motor driver, or breakout board. And what it is, it's an H-bridge controller that will allow you to connect up to two motors, which would usually be 5 volt, and it receives signals from my Arduino board right here, which is a combination breadboard and Arduino controller, which is made by STEM Terra, which is an Arduino Uno R3. And what it does is it takes information from the Arduino board, like the RPM and the speed, or just the PWM signal, which tells the speed, and also other different signals to tell it to stop and the direction. And it will send it to this motor right here. I also have a physical on-off switch that will either send if it's off, it'll just send the motor signal to ground. And if it's on, it'll allow the motor to turn on and actually start spinning. So you can see here I also have the RPM displayed on the LCD screen. There's a bunch of wires connected to the Arduino here that's mainly for parallel data so that the numbers can be sent. And you also have one of these blue wires for the contrast potentiometer. So I can demonstrate what that does by turning this potentiometer. See how the screen on the LCD changes. So depending on the environment, you might want to use a different setting so you can see the screen properly, and also depends on the viewing angle. So right now, what the screen is displaying, it's just displaying the RPM that it's set to. So as I turn the speed potentiometer, see that the estimated RPM will go up. This, of course, isn't the actual RPM, because the motor does not have an encoder to detect the speed. But I just found the data sheet for this exact motor, and I used that and the voltage that I have to find out what the speed should be roughly. So I can demonstrate that. I put this piece of tape on the motor to make it easier to visualize how fast it's going. And let me just put that on real quick. Here's how the circuit, or the schematic, looks inside KiCad. I'm still figuring out how to use this software well and efficiently, but I'd say it looks slightly better than my other projects. I have the that little bend when you're hopping over a wire and they're not connecting, and have everything be parallel and stuff, or at least look readable. But you can see that I have all my major components, like potentiometer here and another potentiometer here. This one is for the contrast control for the LCD screen. So it's getting the 5 volt and getting the ground, and it's sending the signal to the input on the LCD screen. It's just changing the contrast setting on the screen so you can see it in different light conditions. Next, I have the other potentiometer, and that is, of course, connected to ground and 5 volt, which just comes all the way around from here. So it comes from there, goes around there, and comes back here. And that's connected to analog input 0, and that is providing the speed setting for our motor up here. And so next we have the actual motor controller right here. So B and 1, B and 2, those are the ones that are actually connected to the motor, which will go up here. So you can see that. Oh, never mind. I was completely wrong. Oh, B01 and B02, those are connected to the motor. B1 and B2, those are the information provided by pins 4 and 5 from the Arduino. That's the control for the motor, the direction. BO1, BO2, these are connected to the motor, but you notice that I have a switch right here, and so when it's on, it'll be flicked down and it will allow the motor to move, and it'll connect the voltage to the ground and allow it to spin. Otherwise, when it's connected like it is right now, it will just go straight to ground instead. Next, we have the standby pin, which basically when it's on, it's connected to pin 3 right here. And when that is turned high or on, that will basically just tell the motor to turn off and wait for further instruction. Then you also have the main power supply pins, which are of course connected to the 5 volt. And then you also have the PWMB, which actually should be connected. So I'll go ahead and connect that real quick. And that would be connected to, if I'm not wrong, 6. So you can see that right here, I'm going to take this wire, drag it from PWMB, cross a couple of other wires. I'll try and make this slightly neat. That won't work. Let's see if I can do this another way. So right here, I'll try and go up over this wire. And then down, 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 and then back to show that I'm jumping over the wire. I need to corner that there, and then find a way to get to 6. And I will, can't do much here. I can change that later though, if I absolutely needed to. That is somewhat readable. So the PWMB, that's just the main speed control. So that's what their 0 to 255 value is being sent as. And this little highway right here, that is our connection for all of the pins in the LCD screen. This is the main data area where all the information gets sent. And this of course is just the negative or the ground. You have your contrast potentiometer from earlier, and the main power supply. This is also the power supply right here for the backlight, and these two are separate. So you have the backlight power and then also the normal power for the processing. Then you also right here, you have just some pins for different settings on the LCD, but they aren't completely necessary for sending data and having it pop up. This is the code for the circuit. It's pretty similar to one of my previous circuits where I used just the motor driver and not the LCD, but there are a couple of major differences, like of course the LCD library and also the inclusion of the analog read to get the value instead of using buttons. You can see up top that I have the code for including the LCD library, and this right here, it will also identify the pins for the library to tell the code which pins that the LCD screen is using, so that it can send the data to be displayed on the screen. These are all of the pins for the motor driver breakout board. And right here, these are some variables so that the board will work. this is basically just saying which direction it'll be, and this just says what the speed will be. This can go from 0 to 255 as a value. So 255 being full speed and 0 being stopped. Here's the setup code, which only runs once. And this is setting the types for each pin that was set right here. Of course, the serial begin for debugging, which should normally pop up down here. And also, this is to set the size of the LCD, because there's no way for it to know otherwise. So you can get multiple different sizes, but this is 16 characters by 2 characters, which is still not very many pixels, but you can display some text on it. And next we have the main void loop, which will repeat infinitely. And right here, this is getting the speed value for the motor, and it's being received from a potentiometer connected to the analog read input pin. And so the max value that the potentiometer can give, that is 1023, but the max value for our speed is 255. So to get it to that, we have to divide it by this number. And so if I didn't have that, it would just, if I turned it all the way up, the potentiometer from nothing to 0, it would repeat multiple times. And like the motor would go all the way up to full speed, then stop, then all the way up to full speed, and it would do that 4 times about. So this will prevent that and make it so that the potentiometer provides the full range and nothing else. This is the main code that tells the motor, or it refers to this function down here, and tells the motor, or which motor, you can have up to 2 for this circuit, the speed, which is the 0 to 255, and the direction. All this code is for the LCD. This is so that, of course, to prevent overlapping, because if you didn't, you'd have all the numbers being written on top of each other, which would not look very good and be unreadable. This tells the LCD where to put your numbers or text. And this is the code for the RPM. So the RPM, it's not the actual spinning speed, because this motor does not have an encoder to detect the RPM. But what I did is I found the datasheet online for the motor, and I searched up its RPM at a certain voltage, and I found that out. And so I divided that number by the speed x, or did a little math, figure that out. And this is just to make the numbers look cleaner on the display, because without it, they're changing way too fast, and you can't even tell what it's saying. So that's the end of the void loop, the main repeating part. And so now this is the function that the move calls. So whenever this right here is called, it refers to this big chunk of code. And what that's doing is, whenever that's called, this happens. It disables the standby, which tells the motor to start being activated. And this will also create the variables for direction, but we don't really need this. This is irrelevant, really. But this is the main part right here, which basically just tells the pins and sends the information to the controller about the direction and the speed. And this is also unused, the stop. I just have a switch, just a hard switch instead, which I think works better than a code solution, but they both work.